Okay, now this is pretty good. Now, what I want you guys to do, and you'll notice this has sort of magically appeared because I actually just created this sheet. There's a sheet down here at the bottom that says densities. Well, you're going to click on densities, and you're going to notice it has all the different densities of different metal coins. Well, what I'm going to ask you guys to do is going to ask you to go over and take a look at copper. Okay, now copper is 8.96, so that's its density. So let's take a look. I'll go back to sheet number 1, and we're going to put the density of copper. And our known density is 8.96. Now that's actually not too bad. We actually weren't too far off with some of our answers. Alright, so what we're going to do is I'm just going to actually drag this density all the way down. Boom. The density of copper, 8.96, is always going to be the same. Okay, density of... Now, what I'm going to ask you guys to do is like, okay, let's see if we can figure out our percent error. Okay, now what is percent error? Well, percent error is the actual amount, okay, minus what we calculated, and then multiply a okay. Now what we're trying to do is we're trying to figure out the percent error. So what we're going to do is, in order to do the percent error, it's the actual density of copper, which in this case is 8.96, minus the experimental amount, okay, divided by the actual density. All right, so it's percent error is actual. Okay, so we're going to type in equals the actual density minus the density we calculated. In this case, we're going to do the density we calculated by the mass volume error. And then we have to actually put that in parenthesis because we want to do that subtraction first. Then we want to divide by, again, the actual, which is J2. All right, and that's going to give us the percent error. Actually, that's going to give us a decimal, which we're then going to convert into percentage. Boom. All right, now normally what we would have to do is we'd have to multiply this by 100, but what we're going to do instead, we're just going to simply drag this all the way down. Boom. All right, and so in order to convert this into percentage, I'm going to click up here, and there's usually a button here at the top that says percent, boom, and it turns everything on. So my percent error in most of these was pretty darn good. This is the biggest one here, which has a percent error of minus 22, but for the rest of these, they're pretty darn good. They're not very far off. 120, 240%, that's pretty big. All right, but some of these had pretty good errors. All right, now this is the percent error though, and I want to actually label this by measurement. Now let's do, whoops, that was wrong. Okay, measurement. The second one is the percent error displacement. Okay, so again, we're going to take the actual, okay, this equals the actual density minus the density we calculated using the displacement method. We're going to put that in parentheses because we want to do the subtraction first. Then we're going to divide by the actual, again, J2, and hit enter. Boom. And we're going to see what we got for errors here. Okay, click, convert to percentage, and you'll notice that our percentages are significantly off. You know, this was 6, that's a 6 by 7, 2. So there's much bigger error in our displacement error. So as we figured out, we did have much better numbers doing this by taking the measurements and calculating the volume that way. Okay, so that's basically it. One of the things we do have to find though is we actually did pretty good. We actually, the copper was actually pretty close to pure copper, and the density we came out was pretty close. What we're going to do next is we're going to actually take a look at our copper coins, and we're going to do that. Okay, so that's the next part. One thing you should do, though, is you should save this. There is a place for you to upload it now, and you need to save and upload your diagram there.